Video I will be talking about strategy pattern. Before I start with strategy pattern, we must know why design pattern is important and how it is used in our life in terms of software development. So let assume we are on a road and we actually approach a junction and it is not having any signboards and we do not have any people nearby us and we do not have a map also with us, but we have to take the right direction to reach that expected destination. But the situation, right, it will like make the driver get confused, to decide what is the route he need to take. So this was the case in the early days, and this bad experience caused bird journeying experience. So how this kind of problem can be resolved? So that was the thought process. Introduced signboard in our road design. So nowadays, if you get into any junction, you will see a signboard. It will indicate the direction for different location. So based on our target destination, we can take the right route. So what we have done here, so we have used our past experience, and it's a kind of a recurring problem, right? Wherever there is a junction, it can happen. So in similar way, software development, right? There are many recurrent problems when we develop the software. So based on the experience, there are some patterns have been defined. So when we meet such scenarios or such problems, we can use those patterns or we can use those past experiences from our ancestor, to get rid of that uh, problem. So in this session, I'm going to discuss about strategy pattern and to explain how come up with the concept. We are that is, I'm going to build a species demo app and in different phases because my PO has a requirement in phases. And when we complete all the phases, the journey, right, it will actually take us to different problems and we will see how a strategy pattern will help us help me to resolve it. So with that, let me first open the requirement for phase 1. So the phase 1 says the application is expected to print alive and dead behavior of lion. So it's a species demo app basically. So the PO expects me to print the alive and dead behavior of lion. It is looking simple to me as of now. So let me add a code actually for it. I introduce a class called lion. So I have now added the line class. Let me use this line class and print the line data. Let me save this and run the code. So line details is getting printed. Now I have to add the behaviors alive. And then I have to add another behavior dead. So I have defined these two behavior for line. Now as per the requirement I have to print this. Now I have to show a demo to my PU and it is now printing the line details. So and so PU is super happy with the output and he is asking to proceed with next phase of development. In the next phase, the demo application is expected to print alive and dead behavior of tiger. It is looking similar to line. So let me introduce another class. Let me move this class out to the root folder. I'm adding tiger.cs now. I copy paste the code from line because it is looking exactly similar. I had to rename line into tiger. Okay, now I am done with the page 2 requirement. I have to print the result here. So let me show the demo to my PO. Now Line details. Sorry, I missed to replace one more statement. Not line detail, this is tiger detail. So let me show the demo now. Yeah, the line details, tiger details, both are getting printed. The PO is super happy again. But from the developer point of view, what is the thing can be improved actually with the existing code? The line CS, the line class and the tiger class, both are having similar method, right? Alive, dead. So why the code is getting repeated? So how should I reuse the code? Maybe an inheritance can help here. Yeah, it will help certainly. So we will try that. And as lion and tiger are kind of a species, we will add a abstract class called species. So public again, let me copy the code and reuse. Species alone will not make any meaning, right? When we say it is tiger or lion, then only it has some meaning. So when it is the case, we should not implement these classes now a regular class. Instead, we can define it as abstract class. The constructor here is not needed because we will use the respective concrete classes. Okay, species now have implemented alive and dead, and we have to simply reuse that, right? So the alive and dead block can be removed from here, and we can probably extend this class from species. Similarly for line, let me extend the species here. So now as we have defined a species as the base class, we can always create instance and assign to base class type, right? Okay, now we are done with the changes. Functionality wise no change, but technically we have reused the code. The alive and dead behaviors are defined in species, and it is reused in both lion and tiger. Let's see how it runs. Yeah, s- it is functionally there is no change. It is working still fine. Right, we have completed page 2 requirement, and we have to pick up the next item from the backlog. Let's see what is given in page 3. So that page 3, the PO expects the demo app to print alive, dead, and breathe behavior of both lion and tiger. Super easy. We have already defined a species class. If we add one more behavior to it, it will be fine, right? So we'll add a behavior here. Breathe behavior I am adding. What tiger and lion both breathes oxygen. So we can just say breathes oxygen, right? Done. So in the program.cs, I can now let do a demo to my PO, and now he sees the behaviors he asked. Line detail, tiger detail, both are now printing alive, dead, and breathing behavior. And PO is very happy with the outcome, and he wants us to continue the development with phase 4. Species demo of phase 4. So this application is expected to print alive, dead, and breathe behavior of lion, tiger, and mango tree. Lion, tiger, for this we have already done the code, and we have to introduce one more species, mango tree, and it should also have defined these behaviors. Okay, looks simple. We will add one more class, mango tree.cs. Let me add copy the code from here. Mango tree. I think we are done, right? So now we will show the demo to PO. Sorry, PO is not happy because the mango tree details is not printed it. I have to enhance it. So let me create object for mango tree. Mango tree dot alive, mango tree dot dead, mango tree dot breath. Done. We will now do a demo again. Yeah, screen is looking simple. So in the last demo, it is very much clear. We actually print alive, dead, and breathing behavior for lion, tiger, and mango. Oh God, the PO is very much upset because we say mango tree breathes oxygen. It is not the case, right? Mango tree breathes carbon dioxide at daytime, oxygen at night time. But we have made a mistake in our code. So how to resolve this now? So mango tree should not have this behavior. Okay. So then what we can do? What about adding a virtual method in species and override in respective classes? Yeah, we'll try that. We'll say it is virtual, and we can do override. mango tree, right? Breathes oxygen at night. Breathes. CO2 at day. I think we have resolved the problem now. Let's see how the code works. There is some problem. What are those? Sorry, syntax mistake. So now we will see how it works. Now what is that? Okay, I missed a semicolon here. Yeah, it was a problem with the semicolon, so it is fixed. We will see how it is doing now. Okay, so now it is working extraordinarily, right? So now we have get rid of that problem, and the PO now is coming up with pace 5 requirement. So in this requirement, we want us to print the same behavior for banyan tree, right? So what should we do here? It is super easy, right? We can just copy and paste and rename. Can say it is banyan tree. We can change the class as banyan tree. And now we have defined banyan tree, right? We have to print the same here. Spaces, ban. banyan tree dot alive, banyan tree dot dead, banyan tree dot breath. Now let's show you demo to PO. So it is printing line detail, alive, dead, breathe behavior, tiger, alive, dead, breathe, mango, alive, dead, breathe behavior, and then banyan tree, alive, dead, breathe behavior. Correct. Yeah, but functionally it is fine. Technically, we are actually repeating the code for banyan tree and mango tree, right? How should we resolve this? It's a problem, right? So this is a kind of a recurring problem where when the behaviors are not common, right, across families of products, then we may hit this situation. So in this case, the family of species we are building, but some of them are having a different behavior, breathing behavior. So how should we resolve this? And this is where the design principles are going to help us. So first of all, the problem we face here is, you know, due to the inheritance, right? So the for breath behavior, it is not compatible. So we have to compose the breath behavior here. So the design principle says prefer composition over inheritance. And then next design principle, identify the aspects that vary from the items that stays the same. So in this case, the species, right, dead, breathe, sorry, dead, alive, this behavior stays the same for all the species, but breathe behavior is not the same. So it is different, right? So we have to separate it from here, and we have to, build a family of uh, this kind of behaviors, and then we can make them interchangeable at runtime. So that's the design principle, and the pattern that supports it is called strategy pattern. So let me write the design principles that we discussed. So first of all, prefer composition over inheritance. The next is identify the aspects that vary from the from those stays the same. Okay, fine. So now let's see how these two principles can be accommodated using strategy pattern. Now let me add an interface. I breathe behavior.cs. So let me define this interface. So it is interface I breathe behavior. So there are different types of breathing, right? So we will just define the signature here. And then we'll define the oxygen breathing behavior using this implement interface. Oxygen breath behavior.cs, and we can define here. So this is class oxygen breathe behavior, and it should implement breathe function. And we can define breathe oxygen. Similarly, we can define another class oxygen CO2 breathing behavior.cs. Copy the code, paste here. Oxygen CO2 breathe behavior. So it breathes oxygen, or we can name in a better way. Can say tree or plants breathe behavior. Breathes CO2 at day. Right. So now we have defined a family of uh, different behaviors, and it is, you know, based on the concrete sorry base type I breathe behavior. Now we can, so this breathe behavior now encapsulated in a different classes, and we can use those behavior as needed, right? For example, first species should have a breathing behavior, so we have to compose the breathing behavior here. So this breathe behavior can be used here, and this method no need to be virtual anymore. So now in the banyan tree, This override is not required, and we can define the breathe behavior for this. New plant breathe behavior. So we are interchanging algorithms, as per the uh, need. So mango tree, this breath is not required, and we can define the breath behavior here. And then line, line should actually define the oxygen breathing behavior. Similarly, tiger, it should interchange the algorithm with oxygen breath behavior. So now the code is not scattered actually. We have encapsulated the breathing behavior and we are reusing you know uh, in families of classes as needed. Now save all the changes, run it. It got executed. So now the same result, but we have also optimized the code. We reuse the code, right? So this kind of design is called strategy pattern. So if you see the high level things, species is the base class of different species and it is abstract, right? And it defines the common properties alive, dead, breath, right? It is not the aspect that is varies between the different uh, subject. Example, lion and tiger breathes oxygen, but trees, mango tree and banyan tree, they actually breathe oxygen at night and CO2 at day. So this breathe behavior, right, is composed here. And using the composition, we actually invoke the breathe behavior. And this composition, right, it enables us to define the required behavior at runtime. So the two breathe behaviors are oxygen breathe behavior, plant breathe behavior, and both are actually implementing the I breathe behavior. And we have defined the behavior in each classes. So this breathe behavior is completely encapsulated, and the final product it defines what is the expected behavior. So line is a final product. It defined the required behavior as oxygen. Mango tree is the final product. It defined the behavior as plant. Tiger, it defines oxygen behavior. Banyan tree, it defines plants behavior. So with these things, we finally able to, you know, achieve the reusability. So, and this is the design called as strategy pattern. Thank you.